Hi, welcome to lesson 8.4, Proportionality Theorems. Now, one of the things that we're going to look at in this lesson is that whenever you have a certain scenario, for example, when you have a line that is parallel to the base here, we're going to see that some sides are going to be a little bit proportional. So let's take a look at one thing, okay? Let's take a look at this large triangle and this little triangle right here. Now, we know that both triangles, the large triangle and the little triangle, have this common angle right there, okay? Now, because these two are parallel, we know that these angles right here happen to be corresponding, which leads me to the next thing. The large triangle is similar to the small triangle by angle-angle similarity. Now, because of that, we can deduct that some sides are going to be proportional. So we have AE, side AE is going to be proportional to side AC. Okay, how is that? AE to AC. They're proportional. Okay. Now we also know, because they do have the same scale factor, AD is going to be proportional to AB. Now, we're going to start getting a little crazy here with the fractions, okay? So what we're going to do is we're going to derive something that's going to be really cool, okay? But in order to do that, we need to flip both of these fractions upside down, meaning numerator becomes denominator, denominator becomes numerator. And yes, you can do that. It's still equal, okay? So I have AC over AE equal to AB over AD. Now, let's take a look at AC. Segment AC is made up of two different segments, which is AE plus EC. So what I'm going to do is I'm going to replace that with that. Now, AB, that's going to be AD plus DB over AD. Now, one of the things that you're going to notice is that I can split a fraction. Whenever you have two terms in the numerator divided by the same denominator, I can actually split them into two separate fractions. So AE over AE plus EC over AE and AD over AD plus DB over AD. Now check this out. AE over AE, that's just 1. AD over AD, that's just 1. So I technically have a plus 1 and a plus 1. So what if we minus 1 on both sides? That means that I can get rid of these two. And what's going to happen now is that I have EC over AE equal to DB over AD. Now what I'm going to do is I'm going to flip them back. Okay? So AE over EC, well, let me make a little bit left on this one. AE over EC equals AD over DB. Now, how does that affect what we have over here? Check this out. AE is proportional to EC as AD is proportional to DB. Now, why is that even important? Well, what if you were given the lengths of, some of these sides and asked to find, one of the missing sides? So, for example, say I give you these numbers, 7, 3, 5, and x, okay? If I use this idea right here, this ratio, it's going to look something like this. 5 over 5 plus x, okay? And 7 over 7 plus 3. However, if I use my newer idea, it's going to look like this. 5 over x, 5 is to x as 7 is to 3. So now, it takes no rocket scientist to determine that this is going to be way easier to solve than this right here. Now, don't get me wrong. You will still get the same answer as this one. But this one right here is so much easier to solve than this one. So we're going to be using this idea right here to solve for missing sides whenever you have a triangle with a parallel side to it. All right, let's take a look at exploration 2. Now, in exploration 2, you have a triangle and you have an angle bisector. Now, when you have the angle bisector, you're going to create proportional sides. Now, let's go ahead and use the same concept from the last diagram. Okay, that means that I'm going to create a line that is going to be parallel to this line going through this point. So let me just sketch this. So this one and this one are parallel. Okay, I made them parallel. Okay, now what I'm going to do, I'm going to extend this line. Okay, it's just an extension. Right, hopefully you guys can see that. Now, here's one thing, because these lines are parallel, this angle here is going to be congruent to this angle here because of alternate interior angles. This angle here is going to be congruent to this angle here because it happens to be a corresponding angle to this one. Now remember, this line is an angle bisector, which means that these two are congruent. Now looking at this triangle, now I need a point for this one. Looking at this triangle, I have a triangle with a pair of congruent angles, which means that this is going to be isosceles to this. Okay, so check this out. Based on what we learned in the last exploration, we have the following. AD is proportional to DC. And AB is proportional to BE. But what is BE congruent to? Okay, if you look at this diagram, BE right here is going to be congruent to BC because it's an isosceles triangle. So what I'm going to do is I'm going to replace this. I'm going to replace my BE with a BC. So this is my new proportionality. So AD is proportional to DC as AB is proportional to BC. Once again, left to right, left to right. Okay, AD is proportional to DC and AD is proportional to BC. Now let's go ahead and show you guys where the examples are going to go. So let's really quickly go to the next page. Don't worry about this part here at the bottom. You don't need that. Page 238. Okay, so this is where example 1 is going to go. This is where example 2 is going to go, which leads us to the triangle proportionality theorem. It says if a line is parallel to one side of the triangle, this to this, triangle intersects the other two sides, then it divides the two sides proportionally, meaning that RT is proportional to TQ and RU is proportional to US. And it works backwards. Okay, the converse of that. If the sides happen to be proportional, then the triangles are going to be, then the lines are going to be parallel. And yeah, we can do a whole proof about all that, but we're not, unless you want to. Okay, so if RT is proportional to TQ and RU is proportional to US, then TU is going to be parallel to QS. That's where 3 goes. Now, example 4 is going to go right there. Now, this is the 3 parallel lines theorem. If you have a set of 3 lines that are parallel, cut by 2 different transversals, the sides created from that, or the segments created by those intersections, are going to be proportional. So UW is to WY as VX is to XZ. And we're going to be applying that in just a bit. And the last theorem is the triangle angle bisector theorem. That's the one we explored in exploration 2. So AD is to DB as AC or CA is to CB. So we're going to go ahead and apply those in the following examples. All right, let's start with example number 1. Okay, in the diagram, QS is parallel to UT. And they give you that ST is 6, QU is 9, and RS is 4. What is the length of RQ? So we're looking for this. What we're going to do is we're going to set up a proportion. All right, so proportion is going to be really easy. X is to 9 as 4 is to 6. Very simple. Cross multiply. Okay? That gives you 36. That gives you 6x divided by 6. And you get 6 equal to x. So the length of our Q is going to be 6. Simple as that. Let's look at example number 2. Okay, on the shoe rack, they tell you that BA is 33. I really wish I had a bigger picture. Maybe I can zoom in a little bit. Okay, that BA is 33. CB is 27. CD is 44. I know it's kind of hard to see there, but that's a 44. I know what I can do. And then DE is 25. So in other words, let me replicate this because I know it's a little hard to see it. We don't know if that's parallel or not. We'll figure it out. C, B, D, A, E. So you have 27, you have 33, you have 44, and you have 25. We want to know, is this line going to be parallel to that line? So what we have to do actually is we have to set up our proportions. 27 is to 33. 27 is to 33. As 44 is to 25. So the question is this going to actually be proportional or not? So one of the ways that you can see is you can cross multiply and see if the left equals the right. Now, I don't know what these multiplications are, but I do have a fancy calculator. So 27 times 25, that's going to give me 675. 44 times 33, that's going to give me 1,452. So as you can see, these are not equal, which means that BD, okay, is not parallel to AE. Had these been equal, then yes, this will be parallel to this. Oh, can't see that. And that's example number 2. Let's take a look at example number 3. Okay, in example number 3, they tell you in the diagram, angle 1, 2, and 3 are all congruent. Okay? Now, if I'm looking at 1, 2, and 3, they're all congruent. To me, this looks like a corresponding angle. So by the corresponding angle theorem converse, these lines are all going to be parallel. Kind of cool, huh? Okay, so they're telling me that this length is 150, this length is 300, this is 120, and we are actually going to be looking for the distance of HF. But in order to find HF, I need to find out what this is going to be. Okay, so that I can add that to the 120 and find what HF is. Okay, because we know that HF is equal to whatever x plus 120 is going to be. So I need that x to find out what HF is. How am I going to find x? Well, x is going to be proportional to the 120. X is to 120 as 300 is to 150. Now, kind of interesting that this reduces to give you 2. So x over 120 equals 300 divided by 150. That's just 2. Cross multiply and you're going to get 240. So x equals 240, but ladies and gentlemen, that is not the answer because we're looking for HF. So we need to plug in here, substitute, 240 plus 120, and HF is going to be 360 yards. And that is example number 3. Let's look at the last example. Okay, in the diagram, use the given side lengths to find RS. So we need to find out what RS is. So we're looking for x. So here's the thing. This is the part where people get really confused because I am trying to see what the heck is this right here going to be in terms of x. I can barely see that. Let me see if I can get a little different color. Try green. Okay, we need that distance right there. So this is x and this is 15. So this little distance right there is going to be 15 minus x. Okay, So now I get to set up my ratio. Okay, how's my ratio going to look like? Well, it's going to be x is to 15 minus x. Remember, this is to this. Okay, x is to 15 minus x as 13 is to 7. Messy, but you know what? We can do this. Cross multiply. That's going to give me 7x equal to whatever 13 times 15 minus x is going to be. Okay, so let's go ahead and multiply 13 times 15. That's going to give me 195 minus 13x equals 7x. We're solving for x, so I'm going to move this one to this side. By adding 13x, that's going to give me 20x equal to 195. No one said the answer had to be an integer. Okay, so 195 divided by 20 is going to give me 9.75. So RS is going to be 9.75. Thank you again for watching, and make sure you guys do all your homework.